Okay, so this is a set of notes on algebraic proof. All right, so we need a couple of rules to work with here. We have some properties of what we're going to call equality. And these properties are pretty straightforward. We have one that's called a reflexive property, which says that every number is equal to itself. We get a symmetric property, which tells me that if A is equal to B, then B is equal to A, so you can switch things over the equal sign. And finally, we get a transitive property, which says if A is equal to B and B is equal to C, then lo and behold, A and C must be equal. Okay, so those are my properties of equality. I'm also going to get a series of properties of algebra, which you already know, but we just want to name them. Okay, so the first one tells me is what we're going to call the addition property, which tells me that if A is equal to B and C is equal to D, then if I add A and C and B and D, they are still equal. Okay, so this is pretty much saying you can add the same thing to both sides of the equation, and the equation is still true. Okay, so we have a subtraction property, which basically says the same thing but with subtraction. If A is equal to B and C is equal to D, then you can subtract C from one side, and you can subtract D from the other side, and the equation's still true. So you can subtract the same value from both sides of the equation, and it does not change the truth value of the equation. All right, not surprising, what follows this is a multiplication property. And again, if A is equal to B, then ultimately, if I multiply A times C and B times C, this is still going to hold. Or, sorry, C times A and C times B, multiply both sides of the equation by the same number, everything is good. Division has a similar idea, but it is slightly different. If A is equal to B and C is not 0, because you can't divide by 0, then A over C is equal to B over C. So that's our division property. That only holds if C is not 0. Another thing that we commonly do in algebra is substitution, which basically says that if two things are equal, right, so if A is equal to B, then you can replace A with B in any equation or inequality. So if these things are equal, you can take one out, you can put another one in, and the truth of an equation or an inequality will not change. Okay, the last property of algebra that we commonly use is what's called a distributive property, which we've seen before, which tells me if I have A times B plus C, this should equal AB plus AC, right? Multiply the A by the B, multiply the B by the C, and I have the idea of distribution. So we're actually going to prove something using these properties. Okay, so we're going to be given an equation. So here's the equation that we're going to be given. 3x is equal to 6 minus 1/2 x. And we want to prove that a solution to this equation is that x is equal to 12 over 7. So the way we do this is we build a two-column structure, a column of statements and a column of reasons. Okay. So the very first statement I can make that's a accepted statement is that 3x is equal to 6 minus 1/2 x. And why do I accept this? Because it was given to me. So I can accept that because it was a given statement in the problem. Now, what I want to do is I want to progress to get x by itself. An easy thing for me to do here is to multiply both sides of this equation by 2. So if I multiply 3x by 2, I get 6x. 6 by 2 is 12. Negative 1/2 x by 2 is negative x. What did I do to both sides? I multiply both sides by 2, so I use the multiplication property. So that's pretty straightforward. I want to get the x's all on the same side. So if I add this x to both sides of the equation, that should work. So that's going to give me 7x on this side, and leave me with 12 over there. What did I do to both sides? I added something. So that's using the addition property. Okay, and now, if I wanted to, I can get the x by itself by dividing both sides by 7. So if I do that, I'm going to get 12 over 7. I used the division property to do that. And ultimately, I got to what I was trying to prove. Okay, so the key here is it's not like what you can do in algebra. This would have been your algebra class, was this side of the chart. How do I solve the equation and get x? This side is the geometry class. What justifications can I give for each of these steps? How do I make a logical argument deductively that gets me from the first one to the last one? It goes from the given to the proof. It's like, if this, then this. Alright, so there we go. We can use the properties of algebra to be able to solve or to prove the equations and prove that something is a solution to the equation, or to justify the solutions that we find in algebra. Thank you.